today we are going to start chapter 9, okay, and that's beginning with section 1. Now whenever we are starting this chapter, we're going to have to know a lot of definitions because we're going to be referring to these definitions throughout the entire chapter. So today is going to be a lot of information. You need to make sure that you get these definitions written down and understand them so that in future videos, whenever I just mention a monomial or a polynomial, you're going to know what I'm referring to, and you won't have to keep looking back at the definitions. Okay? So to get started, we are going to split section 1 into two parts. This is day 1, and we're going to talk about monomials and polynomials. A monomial is a number, a variable, or a product of a number and one or more variables with whole number exponents. Okay, so here we're getting three different options for a monomial. It can either be a number, like -3, or 17, or 27, or 5,000,000,002. Okay, that's a monomial. It can be a variable, like a, b, c squared, d, z, okay, any types of those things. Or it can be a product. Product means that they're being multiplied together. So it can be -2x squared, or it can be 1.5y to the 4th. Okay, you can have numbers and letters in the same thing. That's also a monomial. But the exception is that we have whole number exponents. So we can't have any negative numbers, we can't have any fractions. Okay? The degree of a monomial is the sum of the exponents of the variables in the monomial. Okay, so we know what variables are. When we have an x just by itself, that means that it has an exponent of 1. Okay, if we have a number written that's there, that is the exponent given. Okay, so if we have something like b times, I don't know, if we have something like b times c to the 4th, we know that this b has an exponent of 1 and the c has an exponent of 4. Therefore, that would give us a degree of 1 plus 4, which is 5. Okay? So that's how you find the degree. So what we're going to do is we're going to go through these examples and state if it is a monomial or not, and if it is a monomial, we want to state the degree of that monomial. Okay? So our first example, we have 3x squared. Is this a monomial? Is it a number, a variable, or a product of a number and one or more variables with whole number exponents? Here I have a number, here I have a variable, and that is a whole number exponent, so this, yes, it is a monomial. Okay? Since it is a monomial, we want to identify the degree. The degree is the exponent. If there's only one variable, it's the exponent given. This one has an exponent of 2, so we have degree of 2. Okay? That's it. Example number 2, we have -3/2 x times y cubed. Okay, we have a number, -3/2, and we have two variables. We have x and y. Okay, when we have this x, that means that we have an understood exponent of 1. Okay, here we are within our definition of a monomial. We have a product of a number and one or more variables. That's a number, one or more variables, with whole number exponents. So yes, this is a monomial. Okay, and this has a degree. Remember, with our degree, we have the sum of the exponents of the variables. So here we have two variables, one with an exponent of 1, one with an exponent of 3. 1 plus 3 is 4, so this has degree 4. Okay? Here, number 3, we have 17. Remember, our definition of a monomial is a number, a variable, or a product of the two. This is a number, so yes, this is a monomial. Okay, here the degree is a little bit trickier, but once you understand this, it'll be a piece of cake. It is the sum of the exponents of the variables. Does this have any variables? No. So since it has no variables, the degree is 0. Okay, degree 0 is allowed. Okay? That is the degree of a constant. And then over here, our last example, we have 3 divided by x squared. Now here we have a number and we have a quotient happening. A monomial is a product, which means we have to be multiplying. So what we want to do is rewrite this as a product. So if we want to bring this x squared to the top, using our properties from last chapter, we can just make that into a negative exponent. 3x to the negative 2. Now, is this within our definition of a monomial? If you said no, you are correct. Because here we have to have whole number exponents. Whole numbers are not negatives. So this is not a monomial. Okay? Since it's not a monomial, then we can't find the degree. So we're done with that one. Alright? That is monomials. Monomial. Polynomials is a monomial or a sum of monomials, and each called a term of a polynomial. So now we're having sums. Also remember that sum you can subtract as well, because subtracting is the same thing as adding a negative. So now a polynomial is basically a bunch of monomials with plus and minus signs in between them. Okay? When you have a plus or a minus sign, those addition subtraction signs separate things called terms. Okay, so here an example of a polynomial would be something like 3 plus x squared minus 7xy plus 4y cubed. Okay, that's a polynomial. These are all monomials in their own individual terms. So 3 is a monomial, x squared is a monomial, negative 7xy is a monomial, and 4y cubed is a monomial. They're all monomials separately, so when we put in addition and subtraction signs, that becomes a polynomial. Okay? And each of these guys is called a term. That's a term. Okay, remember term, because we're going to have to learn how to combine like terms tomorrow. The degree of a polynomial is the greatest degree of its terms. Okay, so what you're going to have to do is evaluate each term for the degree. So using this example up here, 3, as we discussed, has no variable, therefore it has degree 0. So this has degree 0. Okay, x squared, the exponent is 2, so that's going to give us degree 2. Negative 7xy, x and y both have exponents of 1, which that means that 1 plus 1, this also has degree 2. And then we have 4y cubed, which is cubed, so we have degree 3. So which of those is the greatest degree? 3. So therefore, this whole polynomial would take on degree 3, because that's the biggest degree of the monomials, of the terms. Okay? And then the leading coefficient is the coefficient of the term with the greatest degree. So once you identify the degree of the polynomial, you're going to stay with this term, and then the coefficient, or the number out in front, is going to be the leading coefficient. So here our leading coefficient is 4. Okay? So, let's do some examples. We're first going to determine if it's a polynomial, and then if so, we're going to determine the degree, and LC means leading coefficient. Okay? Alright, so 9. Is 9 a polynomial? Yes, it is a monomial. It's not a sum of them, it's a monomial, which is also a polynomial, and it has degree 0. So yes, this is a polynomial. The degree is 0, which means the leading coefficient would have to be 9. Okay? Here, we have 2x squared plus x minus 5. Okay, so is this a monomial? Is 2x squared a monomial? Yes, we have a product of a number and an exponent with a whole number, of a variable, with a whole number exponent. So since this is a monomial, what is the degree of this monomial? 2. Moving on. Is x a monomial? Yes, it's a variable. The degree is 1. And then we have negative 5, sign is included here. If we have negative 5, is that a monomial? Yes, and it has degree 0. So since all of these terms are monomials, that states that yes, this is a polynomial. Okay, the degree, we want to pick the biggest one out of 0, 1, and 2. So our biggest degree is 2. And then since we use this term to determine our degree, we stay with this term and take the coefficient of it. And that is our leading coefficient, which is a 2. Leading coefficient might not always be in front. Okay, like this one up here, our leading coefficient was the last term. So be careful that you're not just picking the first number in the polynomial, that you're actually going to the term that has the biggest degree and taking the number in front of that one. Okay? Here we have 8 plus 4 to the n. So, let's start with our first term. Is 8 a monomial? Yes. That has degree 0. Is 4 to the n a monomial? I have a variable and I have a number, but it's not a product. This variable is in the exponent. Therefore, this is not a monomial, which means no, this is not a polynomial. Okay? And then last but not least, we have 7b c to the third minus 4b to the fourth times c. Okay. Is this a monomial? We have a number and we have a product of 2 or more variables. Yes, this is a monomial. What is the degree? Okay, here b has an exponent of 1, c has an exponent of 3, which means the degree is 1 plus 3. So this has degree 4. Here we're looking at this, negative 4b to the fourth times c. Is that a monomial? We have a negative number. We have 2 variables being multiplied together. Yes, it's a monomial. So this degree, we have b to the fourth and c to the first, which gives us 4 plus 1, which is 5. Since those are both monomials, then yes, this is a polynomial. To find the degree, we want to pick the biggest one, which is going to be 5. And then to find the leading coefficient, we stay with the term that has the biggest degree, which is this one, and we pick the number out front. Sign matters. So here our leading coefficient is going to be negative 4. Okay? And that is part 1.